Hi, Calc BC students. Wow, I miss you guys. Hope you are all doing well. Uh, Definitely want to help you guys out as we are moving forward. We're in our last unit, parametric functions, parametric curves. I've had some requests from students to help them out on some problems, and this is coming straight from our parametric curves day one assignment right here. So we are given some directions here. We're given x equals tangent of t, and we're given y is equal to the secant of t. And we're asked, in fact, to graph that on an interval between 0 and pi over 4. And, the directions are saying sketch them, identify, a function with y and x. In other words, eliminate the parameters so that you can relate x and y directly. Now, they did ask for us to graph here, and I do want really quickly to just point out that with a calculator, this can be done pretty quickly. Obviously, we talked about changing your mode and going from function to parametric, and then you can just very quickly type in x equals tangent of t. To get secant, you have to go 1 divided by cosine. A friendly window might be zoom 4, and right now you're probably graphing between t and 0 and 2 pi. But regardless, I guess what I want to show you is you see this thing. I hope you're remembering something that you've seen in Algebra 2 and in AMA, Accelerated Math Analysis, that this is a conic section, and it looks like it's a hyperbola. And, obviously, as we were to fix this up just a little bit more, if we were to change our window, our T min is 0. That's the standard setting. T max, I'm going to change that to pi all over 4. And, when you do that, you can see that you just get this tiny little section of that hyperbola. We've talked on the video before how, you can have really just like a little table if you're setting that up. And if t were at 0, well, for x, what's the tangent of 0? Well, it's 0. What's the secant of 0? Well, the cosine of 0 is 1, so the reciprocal of 1 is 1. If you were to plug in pi over 4, you could see the tangent of pi over 4 is a 1. And remember, if the cosine of pi over 4, I know in AGT and in Algebra 2, you probably learned it's root 2 over 2. It is. It certainly is. You could also think of it as 1 over root 2. Why would you do that? Well, the reciprocal of that's just going to be root 2 over 1. And if you wanted to get a graph of this very fast, you could say, well, hey, let's see where we're going. We're at 0, 1. Well, here's, pardon me, let's fix that up a little bit. 0 is right over here, and 1 would be right here. And then we'd be at 1, comma, well, radical 2 is about 1.414. So, if you're up here at 2, rad 2 is about right here in the middle. And, you could see that you get something that looks kind of like that. It's just this little piece of that hyperbola. Now, that begs the question, though, how would I eliminate the parameters? How in the world would I ever know offhand that I have a hyperbola, especially if I didn't have a graphing calculator to get us started? Well, this is how. When you're seeing trig functions, no doubt about it, the most famous trig identity, and I know kids have seen it time and time and time again, is sine squared plus cosine squared equals 1. Well, I'm redeveloping, proving, if you would, a new identity right now. And sine over cosine squared is tangent squared. Look at that. Very, very famous kind of an identity. Theta is just an arbitrary variable, so I could definitely say that's like the tangent of t squared plus 1. This would be the secant of t whole quantity squared. Tangent of t, you could say, well, that's x, so we'd have x squared plus 1. The secant of t here is y, so that's y squared. Don't even need those parentheses, really. And then, tell you what, I'm going to move this x squared over, and maybe you remember the positive term is where the direction in which your hyperbola is going to open up. This would be a center at 0, 0. If you saw this back in AMA, you could say, well, we're dividing by a 1 and a 1, so we'd go up 1 step, right 1 step, down 1 step, left 1 step, and might remember we had our box right in there, and the diagonals of the box made your asymptotes, but because y squared is positive, we're opening up in the y direction. Now, I'll be honest with you, the College Board really doesn't, hold you to all of what we just did right here in terms of the conic sections. We're way more focused on calc. But all the same, that's how, if you were given this problem, you could say, how in the world would I ever know how to do it? Hopefully, graphically with the calculator, you can see how we did that. That can definitely get you some help. Hopefully, you can know from these big trig identities, they can definitely lend you some support plugging in for x and y. Hope this is helping. We're going to move on to another problem.